Hi, I'm Reese. I'm an MPhil student in the statistics department. This video will give you an overview of two statistical methods, which are classification and clustering. First, I will introduce some simple examples to let you have a quick understanding on what classification and clustering can do. I will also talk about the differences between classification and clustering methods, when or when not to use them. And after that, I will briefly go through the content to be covered in the workshop, and of course, a summary as your takeaway. Let's say you obtain some data in your research, and you're interested to know if they can be grouped together based on their nature. The data you get can be in any forms, such as ordinal data, binary data, or continuous data. Classification and clustering can help you to group your data into different groups. Let us go through an example. You have a credit card, and banks will use this credit card's data to monitor for fraudulent transactions. How do they do it? They will use a classification model to classify whether a transaction is fraudulent or non-fraudulent. So, the input can be transaction data like date, location, product category, amount, provider, and the classifier will give you the outcome as fraud or not fraud. Say you take pictures of random dogs on the streets and you want to know what their breeds are. You may have many images, and a classification model can help you to find their breeds. For instance, the algorithm tells you this is a bulldog, this is a border collie, or this is a Labrador. The previous two examples are about classification. So next, we have clustering. Imagine data of people making phone calls to each other. How can we use the data to discover any hidden communities which share similar characteristics? So clustering helps you to find different groups. For example, the red group, blue group, green and orange. However, clustering will not tell you what each color group represent. You need to label them yourself. Depending on your understanding of the data, the groups may be students, workers, or elderly. These labelings can be subjective. In this example, you input some phone data, including location, calling and texting intensity into the clustering algorithm, and you will get clusters of different groups. The question now comes, when shall we use classification or clustering? If you have data with correct labels, you can build a classification model based on labeled dataset, and this is called supervised learning. In other words, supervised learning is that you already know what the groups will be, and the algorithms will learn how to classify. In contrast, clustering is used with unlabeled data. To apply clustering, you don't have to know what the groups will be. The algorithm will find groups for you. Hence, it is considered as unsupervised learning. Here are some examples to illustrate the difference between supervised and unsupervised. You have 1,000 pictures of dogs. For each, you know their breed. This is what we call a labeled or a training dataset, since each dog is correctly labeled with their breed. Classification helps us to make predictions on new observations. Say, you have a new photo of a dog, and you want to know its breed. Classification will tell you which breed it is. It's a border collie. However, classification requires predefined dataset. In other words, human supervised. But what if we are in the early phases of a study or don't have the resources to manually define or generate these class labels? This is where clustering kicks in. Again, you have 1,000 pictures of dogs, but they are not classified in any way, which we call an unlabeled dataset. How can we put the dogs into groups so that the dogs inside each group are similar? We use clustering. Clustering helps to divide the dogs into different groups. For example, group 1 and group 2. And you may then later do some research and figure out that maybe our dogs in group 1 belongs to the sporting group, whereas group 2 belongs to the non-sporting group. So what do we learn? We learned that clustering can help you to explore your dataset, and it is usually used in the early stages of study. You can use clustering to help you to formulate a hypothesis for your research. In this workshop, we will first cover 2 examples on classification and 2 examples on clustering. For classification, I will introduce the most commonly used algorithm called the k-nearest neighbors, short for KNN. Even though it's one of the simplest classifier, it has been successful in many classifier problems. In the first example, we apply the KNN classifier to the MNIST handwritten database. In the dataset, there are tons of handwritten digits from 0 to 9 in image form. We will have a hands-on coding session to train a KNN classifier to recognize these handwritten digits. Next, we will apply KNN to understand music. The music dataset contains audio features extracted from music tracks. In this example, we will predict the geographical origin of the music using KNN. So, if your research data is relevant to images or audio features, or you're interested to classify your data, then this workshop might be helpful to you. Moving on to clustering, we will learn about k-means in detail. In k-means clustering, we cluster the observations into k number of groups. For the third example, we apply the iris dataset, which contains different measurements of each flower, such as the length and width of the flower petal. Clustering can help to group the species without knowing what kind of clusters are in the dataset. You can then label the species at a later stage. Also, you can use clustering to define certain subcategories of diseases in medicine. In example 4, we'll be using genomic data to divide cancer patients into different groups. You might be interested to know how similar the genomic data of different patients are, or how do patients who share the same diseases have similar gene expression profiles. So without knowing what each group of patients represents, we can use clustering to divide patients into different groups so that the patients in the same group are more similar to each other than the rest of the patients. So if your research data is relevant to measurements or genomic data, or you're interested to find natural groupings in your data, then this workshop might be helpful to you. As a warning, both classification and clustering should always be studied case by case with the end purpose in mind. There is no one-size-fits-all validation procedure to see how good your algorithm performs. In fact, there are different ways to evaluate the performance of KNN and k-means. Hence, when applying these techniques, it's important to know when to use them and why use them so that you can validate your results accordingly and they can be useful for the particular application you have in mind. In the previous slide, we covered some simple examples to illustrate the concept of classification and clustering. In the workshop, I will go into the details of these examples and let you have hands-on coding practice so that you may apply it to your research. After attending the workshop, you will learn how to quantify how similar two things are. You will also learn about 2 different statistical methods, which are k-nearest neighbors, KNN for classification, and k-means for clustering. Most importantly, you'll get a hands-on experience on 4 different examples which may relate to your research. You will learn how to analyze and visualize your data using R. And lastly, how to interpret your results. If you're interested to learn more about installing and using R, please watch the other pre-workshop videos. So, what are the takeaways? You use classification if you know your groups already, and you are wondering to which group does this new observation belong. On the other hand, you use clustering when you don't know any groups or structure in your data. Perhaps k-means can find them. Finally, classification and clustering should always be studied in the context of its end use, since there's no one-size-fits-all validation procedure. We hope that this workshop will be useful to you. If you're interested in research study about putting your observations into groups in a systematic statistical way, validating classification or clustering structures, applying statistical procedures for KNN and K-means. If you have any questions, feel free to drop me an email. See you in class.